Hey everyone, so today we're going to write some TypeScript, and before we go ahead and go into do some NestJS code, it would be a good idea to actually look at the source API that we're going to be using, and that's going to be the SpaceX API docs here. Now specifically, we're using version 3 of this API. I've been seeing that this may be deprecated, so it might not be available in the future, but hopefully by the time you see this video, this is still up. And whatever current version it is on, it's not going to be too different. Now the endpoint that we're going to be concerned with is the launches endpoint. So this one right here. And when we hit this API, there's going to be this example response. So all of this. And our responsibility as a data source is that we're going to use this and we're going to return a subsection of it. And this is why a type library will come in handy, because we'll be using it to transform this data. So I'm going to copy all of this. And I'm going to use a tool called QuickType. This tool transforms the JSON that we get into valid TypeScript types, or interfaces, if you will. So if we go ahead and click Generate TypeScript, we're going to need to paste it in, and the following TypeScript is automatically generated. It would also be a good idea to rename this to something like SpaceX Launch. All right, I'm going to copy this code, and while we have this, let's go back into our Monorepo. And here I'm going to go into the Nx docs to generate a new library. Now the kind of library that I want to use is the workspace one. Alternatively, you could probably use the node one as well. But this is mainly because I want a library that's agnostic from whatever framework we're using, so that we're able to share it between the front end and the back end regardless of the framework. And I believe all we need to provide is the library name, and I'll just call it types. The dry run looks good, so let's run this. And let's go back to our Explorer. Before I open up the type library, I do want to show that our tsconfig.base JSON, as well as these other files that have been highlighted, have been updated. And the main one that I want is this alias to Space Explorer/types, so that we'll easily be able to reference it in any of our projects. So let's open up types, and we're going to create a new file inside of lib. And I'll just name it spacex.ts. And here is where we're going to paste in all of that automatically generated typings. Also, don't forget in your index file, which is the export, we will also need to add the export here for everything from that file. We do have that other types file here. I'm not too concerned with it. We're going to probably change it up and hold the typings for our data model in there, but we can do that a little later. All right, now that we have the types done, let's go ahead and make our schemas. Let's first make the schemas that are related to launches. So that'll be launch.graphql. And remember how I said that we're going to use a subsection of the API response? This is going to define what subsection that is. So first we'll need a launch site, and that'll be a string. We're also going to want to include the mission, and the mission is going to be its own type. It's going to have name and mission patch. Now mission patch is the image URL that we're going to be using, and the API that we're using offers two sizes of pictures, so both small and large. And we can differentiate those two by using a enumeration here for the patch size. So that will be small as well as large as the only two options that we have. So back to launch, we also want to include the rocket, and we're going to create a type for that as well. So on the rocket type, we just want a name as well as the type of rocket that we're using. And then the last attribute that we want on launch is a Boolean type to tell us whether or not this is booked. And this field is custom to our own API because this is how our users are going to interact with the launches. They're going to be able to book launches or cancel those launches as a trip. Now before we go create our queries, there is one more type that I want to create called the launch connection, and this is for pagination. So on it is going to have the property of launches, and this is going to return us an array of launches. Now the exclamation point or the bang sign is on the outside because the array is required as the response type, but it's not on the inside here like this because we're allowing it to return an empty array. Now this project is going to use cursor pagination, so we need a cursor as well as a boolean for has more. And if you don't already know what cursor pagination is, it's a way of paginating a list of varying sizes, so we don't always have a page size that's set at 20. We can now have just any size, and then has more just saying, is there more to the list or not? Also important, the cursor tells us where we're starting on that list so that we can query a page that isn't from the start. And finally, let's define how we're going to do the queries. As mentioned, launches is going to give us the launch connection, but we're going to ask for the input of a page size as well as if there's a current cursor. I'm leaving both of these optional because we can specify a minimum or maximum page size if it isn't provided, and then cursor could just be undefined if we're getting only the first page. And then finally for launch, to get a specific launch, we're going to need to provide it the ID. Otherwise, we won't know a unique identifier to find it. Alright, while we're here, we could also define our user schema as well. We can do that in another file because NestJS will stitch these two files together so that the in-memory schema is all in one thing. But it's also important to note that the way we're defining these schemas, the user GraphQL schema, is going to be dependent on the launch schema. And that's because a user could have a list of launches as a trip to book or unbook. Now this project's a little unique in that the user is only going to have an email. We're not going to do any password encryption or authentication that way. We'll just have it so that register and login will function the same. And if a user by that email doesn't exist, we'll just create one on the fly. So that means that there's only going to be one endpoint or mutation where we're concerned with registration, and that'll be the login endpoint. And here we're going to return a string, and this is going to be the JSON web token that we're going to use instead of returning the entire user itself. To get the current user with that token, we're going to make a query here, and I guess we'll just call it me, but this is how we're going to get the user. Now we're going to need two more mutations for booking and canceling trips, and these are the endpoints or the mutations that is going to affect the trips that the user owns. Now instead of returning the user back or all the trips back, I'm going to make another type here called the trip update response. And this is kind of for security or safety purposes because we're not only dealing with network requests, but we're also going to deal with database writes. So it would be good to include the success and whether or not a message that comes with it. So for both of those mutations, we'll include both of them and make sure that they're required because even on a fail, we still want to return it. Okay, so both of our schemas are done. Let's go into our NestJS server now. So let's first try to run our server. So that'll be an Nx server. Okay, and we haven't made any code changes. So all we are really looking for on localhost 3333/GraphQL is that we now have the schemas of everything that we added, which we do. So launch connection, mission, patch size. So all of our types here. So let's stop our server and then let's go create the launch module first. And if you're familiar with the CLI, you can do that, but I'm going to use the Nx console again. And we're going to generate a module using this, the name of which is going to be launch. And I believe we also need to supply the project of server. And it looks like it's going to go to source launch module, which is good. Yeah. So let's run that. And we're also going to generate something else. So within that module, we'll need a service, and that will also be under server. And I believe I also want to skip test. Can I skip test? Okay, so I guess I just have to say none on this. And it's going to the right place, so that's good. So let's run this again. And then finally, one more generation, we're going to create a NestJS resolver. So same thing. This is going to be in server. The name is launch. And we're going to skip test. So remove that and run. So with all of that, we should now have a new directory. Oh man, it's in the wrong place. All right, I'm just gonna move this into app. Okay, so we're kind of lucky it didn't actually update the app module because we need to import it here. And I'll just put it on the bottom here as launch module. And that looks good. All right, so now we have a folder with 3 new files, the module, resolver, and service, and then we've also added it to the app module itself. Let's first open up the launch module. Since the service is going to have to interact with an external API, we're going to need to import something. And this import is the HTTP module. And we can do it later, but I'm going to do it right now. We're going to also export the launch service, and this is so that our user module can use it sometime in the future. But as for the launch module, this is all we need. So let's go into our service, which is the first step. So first, I want to make a private variable called API URL, and this is the link to the SpaceX API. We're also going to have a constructor so that we can inject the HTTP service. And just a little bit of trivia, HTTP service is actually just Axios with an observable wrapper around it. But now we can use this service to create our two methods to get all the launches, which in the simplest form is just going to return an http.get to those specific endpoints. So get all is going to just hit the launches endpoint, and then by ID is going to do launches/ID. But remember, we added those SpaceX types for a reason, and that's for data transformation. So we can import the interface of SpaceX launch, and then we can provide it to these two generic gets. So now we have type information. And now we could add a private method here that takes in the SpaceX launch, and we're going to return a launch model. This hasn't been defined yet. We're going to have to do that. So let's go back into our types library, open that up, and we're just going to edit types.ts, and we're going to create that launch model. Now here, I also want to open up GraphQL, because earlier when I said that whenever our NestJS application starts, it's going to generate all the types created from our GraphQL queries or schema files. And that's all of that in here. So our launch model is kind of basically just the launch from that, except we're going to make a few changes. And because of that, we can just import all of the server schemas into this type file and use a little bit of type inheritance to just do extends here. And this is because that is because I actually want to omit the mission and is booked fields from that schema, because this launch model is actually what the launch is in memory, and it'll actually have some extra stuff. Mainly, it's a mission model. Let me explain how this works exactly. So remember that in our GraphQL schema, I could probably pull that up. The launch is returning all of this, except the mission has only two attributes, the name and a singular mission patch. But we can determine what size it is by using this enumeration. So in memory, this mission patch actually has two fields, and it's choosing which one to serve to the server. So to accomplish that in our typing, we actually hold both fields in memory, and then we just serve it up based on whatever the input is from the user. And all of this is important because we actually need to create the launch model from the entire SpaceX launch. And this is still red because we're not actually returning anything, so let's actually make that transformation happen. So we're going to be returning an object here. Okay, so this is a lot of stuff. But most of these are kind of self-explanatory. The site is the site name. It's just inside of the launch site nested property. Such as the mission name has the links as well, and then the rocket has all the rocket attributes. The only thing of note is that the ID here is going to be the flight number. And the reason why we're casting it as a string is just because GraphQL always assumes the ID as it is a string and not a number, so we're just doing that for convenience. Alright, before we go any further, we're going to import a few things from RxJS and RxJS operators to make the transformation a little easier for us. And that's going to be these things, so observable, fork join, and of, as well as map and merge map from the operators. So going back to our methods down here, we can add a dot pipe at the end of we got launched by ID here, and that's where we're going to add the mapping here to change. We can add a map here to change the data into the data format that we want. And just to double check, we can make the return type here to say observable of launch model, and because we get no errors, this is saying that it's correct. And just to show that TypeScript is actually helping us out, if we comment out this line, this is now red because we're giving an invalid type. So for get all launches, it's going to be a little more complicated, but we can start by doing the same thing. So I'm going to add a pipe here, so we can add our mapping here. And since this is an array, we have to map over each individual SpaceX launch and then transform them all individually using data.map. We're not quite done because getAllLaunches needs to return us a launch connection, and we have to do the same thing in our types because this launch connection has the launch model, so the in-memory version of a launch. So let's go back to our types, and we're going to do the same thing where we create a launch connection model, and we're going to replace the original launches with our own launch model array. So back in launch service, instead of launch connection, this will be launch connection model. So in addition to this mapping, we're going to also need to create the pagination mapping, so to add the cursor and has more feature. So I'm going to create another private method helper function called paginate, where we can do that transformation. Maybe if I open it up like this. Okay, so we're going to need three things. We're going to need all the results, which we currently have, but we're also going to need page size and cursor. And we want to return an object that looks something like this. So we're going to need to define all these things. Let's start with the cursor index. Okay, fine, just save that way. So the cursor index is going to be the array index where the cursor exists. And that's why it's inside of a ternary here. So if there is a cursor provided, we'll go do a find index and where we're matching the cursor with the ID. Otherwise, we'll just do 0 because it's the start of the list. Now we can define launches, and this is just going to be all of the results starting from wherever the cursor index is to the end or how many page size there is. And this is important if you remember because getAllLaunches is just going to return us the entire list, and there might as well be like 200 possible launches, so we need to condense it into a page size. And then finally, we also need to provide the next cursor, and that's just going to be the ID of whatever is outside of the list, so the very next ID, which we're using as an optional here because what if there is no next cursor, it's just undefined. And that's what has more does, it's just saying that if it's undefined, it'll be false, otherwise it's always true. And now we've satisfied this return, and you go down to getAllLaunches, and now we could add another mapping, where we would just use that private method of paginate on that data, and we need to provide a page size and cursor. And the only way to do that is if we get it from the input. So our arguments will have to include the page size, which is a number, and a cursor, which is going to be a string. Now I mentioned I want to have a minimum size of page, so let's do 10, and I think that's fine. And this is red because paginate doesn't know what type this is. So let's just add it to the end here as a return type. I don't know why it's saved that way, but it's fine. Why did I need fork join? Oh, that's because we need one more method. All right, so one last method, and this is going to be get launches by IDs. So this method is going to be able to return multiple launches given a list of IDs, so more than one, but it's not going to be all of it, so we don't have to paginate everything. And we can do that by calling the original getLaunchById for each ID. Now because we're doing a fork join on multiple observables, we have to make sure that we're merging all of those observables into just one singular observable. Why is this red? I forgot an S here. There we go. To kind of explain this in Promised Land, a fork join, then a merge map into observables is kind of like awaiting a promise.all. So the end result is just all of them squished together in a list. So I think our service is done. So let's go into our resolver now. And our resolver should be pretty simple. The bulk of the business logic is going to be in the service, and the resolver is just going to return whatever the service gives us. So we need to make sure that we inject the launch service, and then we have two queries here. So it's going to be launches and launch, and that's just going to call get all launches and get launch by ID respectively. Now the last thing to do is actually add the decorators so that NestJS knows that this is a GraphQL query, and then we named the method names the same as the ones in the queries, so we don't have to add any options here. And then finally we get the arguments from the GraphQL query by using the args decorator. So let's do the same for regular launch, and our launch resolver is done. Oh, there is one last thing. So let's generate another resolver. This one's in server, and this is the mission resolver. All right, so let's make sure that we put this in the right place this time. So no test. I'm gonna make it flat, and I believe it'll be app launch. So this will go into server / app / launch / and we're gonna update the mission module. Okay, that's correct, I believe. So let's run this, and let's hope it. All right, perfect. It's in the right place. The mission resolver is gonna be a field resolver. So we're doing a resolve field here, and we're resolving the field of mission patch. The parent is going to be what type this is in memory, so that's going to be the mission model, I mean. And then the mission model has the arguments of size that's provided, so we can get that. And that is of type patch size. And this type actually comes from the automatically generated GraphQL types. But all we need to do inside of this method is do a switch case on the size property, and then return the following mission patch that's already stored in memory. Now, I think in launch resolver, I forgot one thing, and that's that I need to actually label this resolver as launch. But with that out of the way, our launch module is complete. So let's go ahead and test some of these queries at the GraphQL playground, and I believe I have to do a refresh. And let's just do launches. And I want basically everything. So let's just do, okay, I think that's correct. So yeah, let's just do a get here, unknown argument size. Oh, I think this is called patch size, right? What? Mission, oh, it's not on this one. It's on this one. So size, there. Now we get rid of this. And there we go. Everything's back. And we can also do a launch by ID. So let's just provide an ID of 2 and press play. And there we go. All right. So our launches are done. This video is getting a lot longer than I expected. So we'll finish out the user module and authentication in the next video. And I hope you all enjoyed this one, and I'll see you next time.